In the quiet corners of space where light itself dares not tread, there exists something so strange, so violent, so fundamentally impossible to grasp. It almost doesn't feel real. Yet it is. Black holes are real. They are not monsters from fantasy or inventions of science fiction. They are out there, watching silently, born in death, cloaked in darkness, and capable of swallowing entire stars without leaving a trace. But it all begins so simply, with light. Somewhere in the vast arms of a galaxy, a star is born. A blazing ball of fire, forged from clouds of gas, mostly hydrogen, slowly collapsing under its own weight. This is how most stars begin, gentle and slow, gravity pulling, atoms fusing, and light pouring outward like a heartbeat. In that furnace, hydrogen becomes helium. Radiation pushes outward. Gravity pulls inward. And for billions of years there is balance, an ancient tug-of-war played out across the fabric of the cosmos. But not all stars are content to live quiet lives. Some are giants, titans far more massive than our sun. And in their hearts, the war between gravity and radiation grows more violent. They forge not just helium, but carbon, oxygen, and heavier elements, pushing the limits of physics until they reach iron. Iron is the end of the line. No more energy comes from fusing it. No more outward push. In an instant, the star begins to lose the war. The core, no longer supported by radiation, collapses in on itself. It happens so fast, faster than the mind can comprehend. A collapse traveling at a quarter the speed of light. The outer layers crash inward, feeding the core, feeding the darkness. Then, an explosion, a supernova, a dying scream of unimaginable power echoing across galaxies. In that instant, all the gold, the uranium, the rare elements that make life possible are born. It is beautiful. It is terrifying. And when the light fades, it leaves behind something new. A black hole. What's left isn't a thing in the traditional sense. It has no surface, no color, no shape, really. Just an edge, the event horizon. That's the part we can see, or rather not see. A perfect sphere of blackness, darker than anything we've ever known. It's not empty. It's not a hole in space. It's something far stranger. If you fell toward that edge, from a distance time would seem to slow for you. You drift down, slower and slower, turning red, fading into nothing. To the outside world, you'd appear frozen in place, suspended at the edge of forever. But from your point of view, you'd fall through. You'd pass the point of no return. Inside, space bends. Time twists. The rules no longer apply. It's not that we don't understand what's at the center. We can't. The math breaks. We call it a singularity, but that word hides our ignorance. We don't know if it's a point, a bridge, an end, or the beginning of something else. We don't know what happens there, only that no one comes back. And yet, for all their darkness, black holes are not monsters lurking in space to swallow everything in sight. If the sun were replaced by a black hole of equal mass, Earth would still orbit it the same way. We just freeze in eternal night. Because black holes do not pull you in like some cosmic vacuum. You must choose to get too close, to cross the threshold, to surrender to the unknown. What happens then, what happens to you, is something we'll explore next. Because if there's anything stranger than the birth of a black hole, it's what lies waiting on the other side. So, what happens if you fall in? It's the kind of question that lingers late at night, haunting the mind like a half-remembered dream. Not because we're likely to ever do it, but because we can't stop imagining it. What would it feel like to drift towards something that lets nothing escape? What would it mean to face a place where time breaks and space collapses? At first, it might not seem like anything special. There's no sudden lurch, no warning, no pull like gravity on Earth. You float, and then you cross the event horizon, that invisible boundary where escape becomes impossible. Even for light, it's a silent line, unmarked, untouchable. But once you pass it, there's no going back. Not ever. From the outside, everything changes. Someone watching from far away would see you slow down, stretch out, dim, and fade. As if time itself were grinding to a halt, you'd freeze there, forever hovering at the edge of the black hole. But that's not what you feel. From your perspective, time marches on. And something strange happens. The rest of the universe begins to accelerate. Galaxies spin faster. Stars bloom and die in the blink of an eye. Millennia pass in seconds. Civilizations rise and fall. It's like watching the future unfold all at once. Like peering through a window into the end of time itself. But you don't have long to enjoy the view. What happens next depends on the size of the black hole. If it's small, the journey ends quickly. Too quickly to even feel fear. The force of gravity intensifies so rapidly that before you reach the event horizon, the difference in gravitational pull between your head and feet becomes astronomical. One part of your body is pulled much faster than the other. Your bones snap, your skin tears, your cells are shredded. It's called spaghettification, and though the word might sound whimsical, the reality is anything but. You're stretched into a strand of atoms. A thread of you spirals into the abyss, stripped of identity, of structure, of life. But if the black hole is massive, truly massive, you might survive longer. You could cross the event horizon and still feel fine, floating, breathing, thinking. The tidal forces aren't as extreme, at least not yet. In that fleeting silence, there is a strange, terrifying calm, like standing on the shore of a dark ocean, unaware of the tsunami rolling toward you. And then you hit it. Maybe it's a firewall, a searing burst of energy that slams into your body and erases you from existence. Maybe it's the singularity, a place where matter and time fold in on themselves, crushing everything into nothing. Maybe it's something else entirely, something we can't imagine, because the laws we live by no longer hold. It's not just death, it's the end of knowing. There's no signal to send, no final scream. Whatever happens beyond that point happens alone. And what makes it worse is that even our best science fails us here. Black holes are where our equations break down, where our understanding of the universe collapses into silence. Yet, strangely, they might also be hiding secrets. Some physicists believe black holes don't destroy information. They might store it or even funnel it somewhere else. A white hole, another universe, a cosmic rebirth. We don't know. We might never know. All we can do is look at the horizon and wonder. Because a black hole isn't just a monster, it's a mystery, a question the universe keeps asking us over and over. What lies beyond the edge of everything you understand? And somewhere, out in the vast, lonely dark, that question is still waiting to be answered. But even black holes don't last forever. For something that seems eternal, unchanging, and absolute, they too die. Just not in any way we can truly witness, not in a way that fits within our brief little human timelines. Their end is a whisper stretched out across the lifespan of the universe itself. To understand how, we have to zoom in, not on galaxies or stars, but on the emptiest parts of space. Because empty space isn't really empty. At the quantum level, it's alive with flickers of something and nothing. Virtual particles, appearing in pairs, annihilating just as fast as they form. It's like the universe is constantly dreaming, conjuring up matter and wiping it away before it can be real. But near a black hole, those rules get bent. When these particle pairs pop into existence near the event horizon, sometimes one falls in and the other escapes. That escapee becomes real, stealing a little bit of the black hole's energy to survive. It's a tiny theft, a speck of energy here, a wisp of mass there, but it adds up. This is Hawking radiation, and it means the black hole is bleeding ever so slowly. For now, it's nothing. A supermassive black hole loses less energy in a billion years than a candle loses in a second, but this slow leak gets faster. As the black hole shrinks, it radiates more, shrinks more, radiates more. And in the final moments, the darkness gives way to light, pure, violent, magnificent light. Because when a black hole dies, it doesn't fade, it explodes. Not with fire or noise, but with the energy of billions of nuclear bombs. All the mass that once devoured stars and swallowed light is unleashed in one final breath. A bright flare in an empty sky, then silence. But don't wait up to see it. These deaths happen after unfathomable spans of time, trillions upon trillions of years, a Google years, maybe more, long after the last star flickers out, long after galaxies fade into darkness. By then, the universe will be cold, quiet, and empty. And when the final black hole evaporates, it may be the last event to ever happen. No one will see it. No one will be left. Just a memory in the bones of the cosmos. And still, somehow, it doesn't feel like the end. Because black holes teach us something beyond science, beyond space and math and theory. They remind us how small we are, yes, but also how bold. Because we dare to ask. We build machines to find them. We write equations to understand them. We sit beneath the stars and wonder about things that destroy light itself. And in doing so, we chase the very edges of reality. From the death of a star to the collapse of time. From the birth of gold to the final whisper of energy. Black holes are the universe's greatest riddle. And perhaps, just perhaps, by trying to solve it, we become something more than stardust. We become the question itself, forever reaching, forever falling, forever curious.